Okay, I'm gonna try and do two problems at once. I know I messed up in the last one. I didn't note to reject or fail to reject. We reject the null from number 17. So number 18. I'm trying to slow down a little bit. The test statistic, again for all of these, the significance level is 0.05 for all of these. The test statistic in a two-tailed test this time, okay, we're told it's a two-tailed test, is 1.95. So if we're going to sketch that, I'm trying to get a nice little sketch. If we're going to sketch that, we have 0 here. Two-tailed, that means that our significance level is split, right? It's a two-tailed test. So this is alpha over 2 in this case. So 0.025. And we are testing this z alpha over 2 versus this z of 1.95. So this z alpha over 2 with an area of 0.025 is going to be equal to 1.96, positive 1.96. So relative to 1.96, we know that the 1.95 is going to be right before it. So looking at that picture, since the test statistic falls within the non-critical, it doesn't fall within the critical region, we should fail to reject the null hypothesis. But this question is asking us to calculate the p-value. And in this case, for the p-value on a two-tailed test, this is important, p-value on a two-tailed test is going to be equal to twice the area to the left of a positive test statistic. Okay, so we have to calculate this area right here, which is going to be slightly bigger than that, right? And then multiply it by 2. And then compare it to the significance level. So how do we do that? Well, we compare the the test statistic 1.95. You can go to the table and find the area to the right, or just do the normal CDF from 1.95 to a very large number, basically infinity in the calculator. And we get an area of 0.02558 about. But that's for the area here. So if you think about this, we multiply this by 2. So we get the p-value is actually going to be equal to 0.05118 about. And then we compare this p-value to the significance level, and we see that it's greater than. So since the p-value is greater than significance, we're going to fail to reject the null hypothesis for number 18. Okay. I'm going to try and move to 19 on the same piece of paper. All right. With the alternative hypothesis stating that proportion is not equal to 3/5. So that's, okay, this tells us that this is two-tailed. Because not equal to is not saying greater than or less than, it's specifying one direction, it's saying not equal to. So that means it doesn't matter if I'm bigger or less. I could go in either directions to prove this wrong. Or to reject it anyway. So it's two-tailed. So that's all that this is doing for us, showing that it's two-tailed test. And the test statistic is 0.78. So I'm going to sketch a little boom, boom, boom. I do better when I don't look. That P is not equal to 3/5. Test is so that, again, significance level 0.05. So it's going to look very similar to this picture here. And the same, that's why I put them together, the same critical value, Z alpha over 2, is the same. 1.96. And the test statistic, 0.78, is going to be like here. So we already know the answer, right? We're gonna fail to reject this thing again, but we still need to just show the work. We need to calculate the p-value. So the p-value is twice the area that would be to the right of this positive test statistic in this two-tailed test. So all this orange. So again, you can use normal CDF to calculate the area here, and then take this area and multiply it by 2, because the p-value again is twice the area, 2 times the area in a two-tailed test. It's kind of a simple way to remember it. 2 times the area in a two-tailed test. So we get the p-value equal to 0.435, a very large p-value, which is much greater than the significance level, so we're going to fail to reject the null.